Hello everyone. Welcome to our video for today. So this is the continuation of our previous videos. We have part 1, part 2, part 3 for our logic gate design. So we started with making our own truth table. So after that one, we also create a function out of this truth table. And by the way guys, if you don't remember, in our previous videos I said that this function, or this truth table rather, function of f output, is we're the one who decide to have that output out of the three combinations of inputs. So we decided to have an output of function of f is 0 0 1 0 1 1 1 0. So that's our personal choice of outputs. So we, out of this truth table, meaning I'd like to emphasize that if we want to make our own logic design, logic circuits, so we have to start with thinking of what output we want to have in our design. So by this example, we decided again that our output f is 0 0 1 0 1 1 1 0. Okay, so out of this truth table that we created, we obtain a unsimplified function. Then after that, we simplified using key map method. That one, we discussed that already in our previous video. And also we have here the implementation of this simplified function, y z bar plus x y bar. This is a simplified implementation of that function, using 5 gates, 2 inverter, 2 AND gates, and 1 OR gate. So, and also in our previous video, I show you also the difference between the unsimplified function and implemented using logic gates. And we have lots of gates to be used to implement that long function. But in simplified function, we have just the term is only the remaining term or variables are only y z bar plus x y bar. Only 4 variables remain out of this long function. X 3 6 9 12 variables, then reduced to 4 variables. Okay, and now this simplified logic drawing, we implement that one using actual ICs. We have here an inverter gate or gate. We have here AND gate. We have here OR gate. So, and also our output, this output LED that represent our F output here, I also connect to an array of relay to interface this logic gates output to 220 volts load. or 220 volts bulb here. So this is the interface, the array of relays. We're just using one relay here, this one. So because we have only one load here, represent this small LED output here, this one, the bulb. So if this LED will turn on, representing 1 here in the truth table, then this will also turn on. So this is they will synchronize because they have the same. And then the only thing here is this is 220 volts and this is only 5 volts. So this really driven by our output here. We connect this blue wire that's connect to the input or trigger point of this relay, particularly this relay. And the output here, this is 220 volts. As you can see, we plug in this one in 120 volts, then this one, and connected to the normally open relay, because this relay has two contacts, the normally closed and normally open. So we connect this in normally open contacts, so that when this relay supplied by our output here in the logic circuits, from the logic circuits, so this will drive this relay using some small components here like transistors, diode here, and the photocoupler, that one. So just to because this is a low voltage circuit, this is 5 volts only, and this is 220 volts here. So this is our interface, right? And this is also how, if you want your output, all your outputs in your project, you want to drive a motor, or you drive like a bulb, right? Or whatever, appliances, your TV, your everything, like automatic door. So this is seems like automation. No, you want to have a design of like automating everything inside your house, like using some sensors. So this would be your interface between the 220 volts load and your digital circuit design, whatever design you have. So let's start, and also we'll do it manually. This one, this X, Y, Z. We use, or we made 3 or actually 4 switches, a toggle switch that represent our variables here, X, Y, Z. We have 4 toggle switches. This is W, X, Y, Z because it's intended for 4 bits inputs, and in our example here we're just using 3 bits or 3 inputs, X, Y, Z. So we're just using X, Y, Z switches. Now let's start. So say 0. Now this is the proof, or rather prove. We have to prove that our output here in our truth table will be displayed. What is really in the truth table will be displayed here in our output, and with this 220 volts bulb. So let's start. Like we start with 0, 0. So all switches are in 0 position, so the bulb don't light on, and also the LED don't light on, and the bulb also. So like the next combination is 001, still the output is 0, so Z is 1, so we have to switch this Z to 1. So still we don't have an output. Then we'll put it back to 0. Then next is the 010. So we expected to have an output of 1. So expected that this display will goes on, and the bulb as well. So we'll try to switch this Y to 1 here. So Y to 1 here. Okay, switch. Look at that, our output lights on. This one also, the 220 volts, okay, goes on. Now we off this Y, put it back to 0. What will happen to our output? Okay, it's off. Also here it's off, so I put back to 0. Then the next combination is 011. It should be output 0. So 11, so no output. 11, 011. Then put it back to 00. Then next is 100. So output is 1 here. See, look at that. That's 1 1 0 0 1 1 0 0 1 1 1 1. Okay, so we 0 again this X. Then the next combination is 1 0 1, output still 1. So X is 1, Z is 1. So still output, we have output. Okay, we have output. Output here is 1. This one. Now next, to 0. Next is 1 1 0. X is 1, Y is 1, Z is 0. X is 1, Y is 1, X is 0. So look at that. We have output. We have also output here. Okay, and finally 1 1 1, output 0. 1 1 1. Okay, so output is 0. 1 1 1. Okay, all ones, 0. So as you can see, we really follow our output. So our design is actually you can see perfect in terms of following this truth table, and of course simplifying the function and implement this in actual. So everything is of course correct, no problem. So our next project, we will try to reverse this output. This one, instead of 00101110, will reverse that. We will reverse that one in our next project. We'll reverse this one to 1 1 0 1 0 0 0 1. We'll see if we can still follow that output in our actual implementation, and of course in our simplifying whatever the function we get here in our next output will be implemented correctly. All right, that's all for now, guys. Wait for our next video for this output again, another output that we want to have in our design. Thank you so much, guys. Bye.